Welcome to Translation of Graphs Part 2. So today we're going to look at two more rules for translation of a graph. So the first one is, if we replace the x with a negative x, this actually reflects the graph over the y-axis. So e.g., if we have y equals f of minus x, so wherever an x is, if there's a minus x, it flips it over, reflects it over the y-axis. So our first example is a sketch of 2 to the minus x. So we know that 2 to the x is an exponential. So we know what an exponential graph looks like. But the effect here is on the x value that's up the top. So the exponential part of it. And that is we're multiplying the x by minus 1, which means we reflect it over the x-axis. So if you can picture your original exponential, and now you're going to flip that over the y-axis. So here we have the two graphs. The original, y equals 2 to the x in red, and y equals 2 to the minus x. So y equals 2 to the x is concave up, and it is pointing, it's always increasing. As the x values get larger, so does the curve. You can see though with the other one, it passes through 1 as well on the y-axis. Still concave up because it's still pointing up. But it's now decreasing. So as the curve, as the x values get larger, the y values get smaller. So it's decreasing as we approach. So the next one, the rules for translation of a graph, is when we multiply the function by minus 1. So the whole function. This reflects it over the x-axis. And we saw a good example of this when we did parabolas. When we did x squared and we put minus x squared, it rotated it over the x-axis, or reflected it over the x-axis. So now we're looking at minus of any function. So we've got three examples of this. So we've got minus 2 to the x, minus x cubed, and minus 1 over x. So let's have a look at each of those individually. So here's our exponential, 2 to the x. So we know that 2 to the x is a concave up, always increasing curve. Now we're going to do minus 2 to the x, so we're going to reflect it over the x-axis. So there's our original graph in red, 2 to the x. There's our new graph flipped over, reflected over the x-axis, and you can see it's now concave down, it's pointing down. So as the x values increase, this curve is decreasing at a rapid rate. Minus x cubed. So, firstly, it's a cubic, x cubed, and it's times by minus. So the original x cubed is going to be reflected over the x-axis. So the red is the original x cubed, and if we reflect that over the x-axis, we get something that looks very similar, just it's graphed the opposite direction. So that's our minus x cubed, both still passing through the origin. And our final one is minus 1 over x. So this is a hyperbola that we have reflected over the x-axis. So note that originally the red one, y equals 1 over x, was in quadrants 1 and 3. When we reflect it over the x-axis, it still approaches the x and y-axis, but now the hyperbola is drawn in quadrants 2 and 4. Final one. Now let's put it all together. What we learned from part 1 and what we've learned from part 2. So this is a hard example, so we're going to break it apart one step at a time. So we've got minus 1 over x plus 2 minus 1. So hopefully straight away you can tell what type of graph that is. Because remember, we're picking from our three graphs. Is it an exponential? Is it a cubic? Or is it a hyperbola? Hopefully you picked that it was a hyperbola. So that's step 1. Can we at least acknowledge what the graph is? So we're going to take the minus that's in front of that hyperbola. So it's the function multiplied by minus 1, which means it's reflected over the x-axis. So from what we've just noticed, that means instead of being in quadrants 1 and 3, it's going to be in 2 and 4. Next, we'll have a look at the effect on the x. So the effect on the x is x plus 2. So we know that that means it shifts at left 2. So x equals minus 2, meaning a shift of left 2 on the x-axis. And finally, an effect on the function at the end is a -1, moves it down 1. As the following graph. Notice that the quadrants 2 and 4, that's where our graph goes in, that's where our hyperbole is sketched. We've shifted the x-axis, so we've shifted the x across 2, giving us a new asymptote at -2, so that's the green at -2. And we've shifted the axis, the horizontal axis, or the x-axis down 1, and we go to -1. So that's our new asymptote for there. Thank you.